So, this is our third to last lesson, which the last two lessons kind of go together. But basically, last time we had talked about parallel lines and that the slope was equal on them. Well, the counterpart for parallel lines with this is perpendicular lines. Now, perpendicular lines are a little different. Essentially, the way I think about it is we have three different types of line pairs. We have our parallel lines, the ones that never cross. We have our collinear lines, which are lines that overlap each other. They should overlap each other perfectly, but you get the point. And then we have our last set, which are our perpendicular lines. Well, sorry, intersecting lines. Intersecting lines are ones that just cross through each other. And today we're going to talk about a particular type of intersecting line. We're going to talk about what we know as perpendicular. Perpendicular lines, which again, all these things we've talked about before. Perpendicular lines are two lines that cross through each other and they form a right angle. So like this one goes perfectly up and down, perfectly left and right. They intersect each other, and if we were to find the measure of this angle here, it'd be a right angle. So perpendicular lines are two lines that intersect and form right angles. So what we need to do today is figure out how to recognize if lines are parallel by looking at their slopes. Again, slope is m. It's our rise over run. That shows the direction and the steepness of the slopes or hills of the lines, if you want to think about it. So there is a term in math called an opposite reciprocal. I'm gonna hope I'm spelling this. Yeah, opposite reciprocal. What an opposite reciprocal is in math is like if I gave you the fraction 3/2. Okay. Well, there's two parts. Opposite is the first part. What that means is it's going to be the opposite of 3/2. So if we go back to a number line and say that we have 1, 2, and -1 and -2, 0, of course. So if we look, let's say we have a 2 right here. Well, on this number line, what's the opposite of 2? Well, what that means is if I were to draw a line in the middle here, what is the same distance from 0 on the other side? So if I went from 0 to, well, I don't use that one. If I went from 0 to 2, I went out 2, but I went 2 to the right, or 2 positive. But then if I were to want to know the opposite, I would go 2 to the left, or negative, and that would be -2. It's the same number, just one's positive and one's negative. So here, opposite means that since this is a positive 3/2, the opposite of 3/2 is negative 3/2. Which again, this is two parts. We have opposite and we have reciprocal. Now for the reciprocal side, let's say we have, well, let's just use 3/2 again. Reciprocal is a bit more complicated to explain, but the basics of it are the numerator and the denominator swap. So the 2 goes up top and the 3 goes on the bottom. So the reciprocal of 3/2 is now 2/3. So when we combine, so the opposite of a number is just the same number with a different sign. The reciprocal is we take that number and we flip it. So 3's on top, it's now on the bottom. 2's on bottom, now it's on top. But again, we have the opposite reciprocal. We have to do both of these at once. So it's actually, to be honest, this is not that hard to do. It might seem confusing, but once you get the hang of it, it's not bad. So opposite reciprocal means we're doing both at once. So again, let's use our example of, which I'm going to adjust this down here a little bit. Not quite what I was going to do, but you know what, it's fine. So let's use our example of 3 over 2, okay? So if I want to find the opposite reciprocal, I know if it's the opposite, since 3 over 2 is positive, it's going to be negative. And I know the reciprocal of 3 over 2 is 2/3. So boom, negative 2 over 3. So the opposite reciprocal of 3/2 is negative 2/3. So you flip the number and change the sign. So for example, if I said that, let's get that, I had 4/5. The opposite reciprocal of 4/5, this is positive 4/5, so it's negative. I flip the number, 5 over 4. It's that easy. You flip it, change the sign. If I had negative 6 over 7, that's a negative, so my new one's positive, and I flip it, and it goes to 7 over 6. That's all you gotta do. That's an opposite reciprocal. So for perpendicular lines, they have to have opposite reciprocals. For their slopes have to be opposite reciprocals. So if I have the line y equals, let's just use our 3/2 that we used before, x minus 4. Well, an opposite reciprocal of that would be like y equals negative 2/3 x minus 4. So for these, all you have to pay attention to is the slope. With parallel lines, we had to pay attention to both numbers technically, but if these are the same, it doesn't matter. They could be the same or different. What's important is the slopes. This is 3/2. This is negative 2 over 3. So what to check and see if they're opposite reciprocals? Do they have the same sign? No, this is positive, this is negative. So that's good. So they're opposites. Are they reciprocals? Well, the 3's on top over here, and it's on bottom over there. The 2's on top here, but the bottom there. So yeah, so they are perpendicular. For example, if I gave you a question where I said that the slope of one line is, I don't know, 1/4. What is the slope of the other line? Given that these two are, again, perpendicular. Well, again, perpendicular lines have opposite reciprocal slopes. So easiest thing to do first is this slope is positive, so this slope has to be negative. On this one, 1's on top, 4's on bottom, so if we flip that, we have 4 on top and 1 on bottom, which we can simplify this to be negative 4. So either of these two are correct, just whichever one you want to use, unless I give you something specific. So again, let's say we have two perpendicular lines. One of them has a slope of negative 8 over 3. What is my other slope? This is negative, so my other slope has to be positive. 8's on top, 3's on bottom, so they flip. I mean, even if I were to go and do something a little more complicated, like point slope form, where it's y minus 3 is equal to 7/5 x, 7/5 times x minus 2, and I wanted to, let's just do this for a second. Okay. If I gave you this line in purple here in point slope form, and I asked for a line that was perpendicular, all you have to look at is this number right here and the number in this slot here. You don't have to look at two numbers. So if this is 7/5, what should be here would be -5/7, because this is positive, this has to be negative. 7's on top here, so it should be on the bottom here. 5's on the bottom here, so it should be on the top here. And that's really all there is to this lesson, is just recognizing that perpendicular lines are opposite reciprocals and being able to. So the hardest part about this is remembering that remembering the difference between parallel and perpendicular. Okay, because parallel lines, if I scroll all the way back up here, they should have the same slope. Their slope is going to be equal. It should be the same exact thing because they're going the same direction. If they're going the same direction, then their slope should be the same. Perpendicular lines, they're not going the same direction. They're going about as opposite of a direction as you can. This one's going left and right. This one's going up and down. So they have to be different. They're opposite reciprocals. So distinguish between the two. And just as a little example of what one would that was look like, let's say we had let's go back to slope intercept for a second. Say y equals 4/7 x plus 2. And then let's do one with the opposite reciprocal. So we have y equals, so the opposite reciprocal of 4/7. 4/7's positive, so it should be a negative. And then we need to flip our numbers. And we'll do -3. Okay. So as you can see, these intersect. Now there's not really a way for me to show you the angle on this, but this would be a right angle. So, and even if these were the same last number, still going through at a right angle. It's just, basically these two numbers at the end just change where they intersect, but doesn't change the direction the lines are going. Now, for example, just for the sake of being thorough, if I were to say get rid of that negative sign, oh, well, that's not exactly perpendicular anymore, is it? No, it's not. And if I were to have a 4 on top and a 7 on bottom, it's not perpendicular either. Looks a bit better, but we can kind of see that this angle is a bit bigger than that one, so they're not all 90. And if I were to, which we'll change that just for a second, were to, let's say, get rid of that negative sign, the parallel. So basically, they have to be opposite reciprocals in order to meet the criteria of being perpendicular. All right, if you have any questions, just let me know.